My plan for today is to pretty much just go over some of the extra problems sets. And I also want to discuss the pirate ship problem, which is in your problem set 5. I know that there's a solution to that was posted online, but I think that even still, it's a little hard to understand conceptually. And so I think that's like a really tricky problem that encapsulates a lot of different concepts. So we're going to do that. Also, looking forward to next week. I know that you guys have your midterm on Thursday. I do want to warn you that due to Veterans Day, I'm not able to have my lecture on Wednesday. So that'll be canceled, which means that the only time we officially meet next week is on Monday, unless you guys choose to go to drop-in hours. But yeah, so we will be meeting Monday where I'll just go over some old midterms probably. All right, sorry about that. So yeah, just like a little bit of a forecast for the week ahead. But with that being said, I do want to kind of get into the pirate ship problem in particular. This was in your problem set 5, so if you guys want to open that, it's problem 4 in problem set 5. And then I'm going to just kind of write down like the information that the problem gives. So 2 period journey. So they have M1 equal to 100. M2 is equal to 0. And they have to make a decision between consumption in period 1 and consumption in period 2. And that's going to be decided by their utility function, which is equal to C1 times C2. So it's a Cobb-Douglas equation with exponent 1 for both C1 and C2. All right. And so we're given that rats will eat 50% of any food that is saved for period 2, meaning that if they don't eat anything in period 1, then their consumption in period 2 will be 50 because it's reduced by 50%. Okay, so the part A is asking for the real interest rate, right? And so if you guys remember, the real interest rate is denoted by 1 plus rho, which is equal to 1 plus r over 1 plus pi, right? In this particular situation, you can kind of think of the rats eating 50% as either a change in the monetary value. So when I say that, it's basically just a change in the nominal value, right? Meaning that if you were to store your money, which is the barley in this case, in a bank, it's actually going to decrease in value by 50%, right? And so because of that situation, you're going to say that your R is either negative 50%. Another way of thinking about that is that in period 2, you can buy half as much as what you could buy in period 1, which is also going to mean that inflation is going to be 100%. So you can either choose between saying that R is equal to negative 0.5 or that pi is equal to 1. And does everybody kind of understand this? I think that this is going to be important as we move forward in the problem because this information is going to be really useful. But do you kind of see how I can make that assumption between deciding that R is equal to negative 0.5 or that pi is equal to 1, right? In both situations, that's going to mean that 1 plus rho is equal to 1/2, right? So the way that you can kind of just prove that is that if R is negative 0.5 and pi is 0, then that means that we have 1/2, so 0.5 over 1, which is 1/2. Or if R is 0 and pi is 1, then we get 1 over 2, which is the same thing, right? So you can kind of see how either way, the real interest rate is going to be rho is equal to 1/2 minus 1, which is equal to negative 1/2 or negative 0.5. Okay. So hopefully that part of the problem is pretty straightforward. But I think that the biggest thing for you guys to kind of understand conceptually is that this could be either a shift in the nominal interest rate, or it could be an increase in inflation. So you can kind of think about it in either way, right? So we'll keep that in mind. So erasing this, we're just going to say that rho is equal to negative 0.5, right? And so let's move on to part B. Now assume that they can attack another ship in period 2, stealing 300 bags of barley. How many bags would the stolen barley have been in period 1, right? So this is kind of like a present value question that they're asking. And so this refers back to sort of the stuff that we talked about on Monday, where if we're talking in present value, we have to divide by the real interest rate. So if you think about it on this like timeline, so period 1 and period 2, they get 300 here, but you have to value that in period 1, right? And so the way that we're going to do this, right, is by taking our 300 and dividing it by 1 plus rho, right? And we're only going to divide it by 1 plus rho to the power of 1 because it's only moving back 1 period, right? And so this is going to be equal to 300 divided by 0.5, which is going to be equal to 600, right? So essentially what it's saying here is that that 300 bags of barley in period 2 is equivalent to having 600 bags of barley in period 1, right? Meaning that if you start off the journey and you have 600 bags of barley in period 1, the rats, which are going to eat 50% of all the food that you have, will reduce it down to 300, right? So as a result, part B is going to be 600. All right. And
so
moving on.
To clarify, if you're going with the nominal interest rate, you're going to say 1 plus r. And then if you're going with the real interest rate, you're going to say 1 minus pi.
So the real interest rate is 1 plus rho, right? If you remember, 1 plus rho
Plus
is
rho.
equal to 1 plus r over 1 plus pi. And we decided in part A that the effect of the rats is either a decrease in r or it's an increase in inflation, right? Was that concept kind of understood? And don't worry if it's not, because it is a little bit complicated to understand. But yeah, pretty much this information results in this, which is what we're going to be working with.
Okay, and so it's a negative 0.5 because it's not interest that's being added, it's something that's taken away, right?
Yeah, exactly, yeah.
Okay.
Right. So the total 1 plus rho, this is a positive amount, but because they're only asking about rho, right, you have to divide by 1, or you have to subtract by 1, right?
Yeah, that makes sense.
Okay. All right, awesome. So
I don't think we finished part A. It also asks how much does the captain choose to consume in each period, and I don't think we answered that part.
oh yeah, we didn't. Okay. So let's actually, because I haven't done one of these with you guys. So we have to remember that we have an intertemporal budget constraint that looks like C1 plus C2 over 1 plus rho is equal to M1 plus M2 over 1 plus rho, right? And the only thing that we don't know are C1 and C2, right? We have the information to plug in everything else, right? So the way that we want to do things is recognize that we're still going to have a utility function, meaning that we're going to have an MRS, right? And so what I said about all of these problems being different topics, but the same concept, right? This is like the exact kind of situation I'm talking about, where pretty much you're really just going to be setting an MRS equal to a price ratio. So in this case, the MRS was equal to C2 over C1, right? Technically negative, which is just an extra detail. And we're gonna set this equal to our price ratio, right? We first have to check that we have diminishing marginal rate of substitution, which you guys can see that we do, right? Because as C1 increases or as C2 decreases, this value right here is gonna go down. And so we're gonna set negative C2 over C1 equal to the price ratio, which if you'll remember, the price ratio for the intertemporal budget constraint is just gonna be the real interest rate. So we set this equal to negative 1 plus rho. The negatives cancel out. Whoops, so let's just erase that. And we get this, right? And so C2 is gonna be equal to 1 plus rho, which is 0.5, which is equal to 0.5 C1, right? And so now we can actually plug this information into here, and we get that C1 plus 0.5 C1, right? 1 plus rho is also 0.5, is equal to M1, which was 100, I believe. Yeah, 100, plus 0 over 0.5, right? And so we can cancel out this 0.5 and we get that 2C1 is equal to 100, meaning that C1 star is equal to 50, right? And because we know that C2 is half of C1, that tells us that C2 star is 25, okay? Were there any parts of this that were maybe a little bit confusing?
How did you get 2C1?
2C1, okay. That's because if you look at this left side, I have C1 plus 0.5 C1 over 0.5. The 0.5s are just going to cancel out, and so you get C1 plus C1, which is just two copies of C1. Okay, and so the optimal bundle that I guess the captain, yeah, the captain is going to choose C1 equal 50 and C2 equal 25, right? Okay. All right, so C1 equal 50, C2 equal 25. All right, so let's move on to part C, right, where we're given a new piece of information. Assume that they have a garden on their ship, so whatever barley the captain chooses will grow into 1.5 times as much barley in period 2, right? And we know that the barley is still going to be subject to an attack on rats, right? And so you might be thinking, like, what are we going to do with this information that's given to us, right? The idea that the plants will grow into 1.5 times as much, right? How does that fit into the question, right? And so this kind of ties back to part A, where I mentioned that 1 plus rho is equal to 1 plus r over 1 plus pi, right? And so we have the option of either saying that r is equal to negative 0.5, or that pi, or that pi was equal to 1 and r is equal to 0, right? So we had this option of saying that either the nominal interest rate was negative 50% or that the inflation rate was 100%, right? And I feel like everyone felt pretty comfortable with that, right? And so now this is where it becomes important that we had these options between the two, right? Where we could either choose between this one or this one, because now I think that the idea of a plant growing into 1.5 times as much is like perfectly aligned with the idea of a nominal interest rate, right? I think it's more intuitive to think of it that way, where pretty much if you were to store your barley in a bank, it'll grow, right, into 50% more, right, 1.5 times as much. And so I think that in this kind of situation, you want to think of this as being r is equal to 0.5, right? Now, because of the options that we chose here, we want to assume that basically in part A that we chose pi as being equal to 1, because now we have a value for r and we have a value for pi. Whereas if we didn't know that we could have used pi is equal to 1, we would have been kind of stuck because we would have had 2 values for r and nothing for pi, and it would have been really confusing, right? So in this situation, in part C, we're going to say that r is equal to 0.5 and that pi is equal to 1, right? Because the pi is equal to 1 captures the effect of the rats, and the r equal to 0.5 captures the effect of the plants growing into 1.5 times as much. Does anybody have any questions about that? I think that the hardest part is the setup, right? Understanding that you can set this equal to this and that this equal to this, right? Are there any questions about that?
I have a question.
Yeah,
I
what's
just
up?
don't know why pi is equal to 1. Like, how did you get that for your inflation rate?
So
From having
that's a great question. So this is stemming from part A, right?
Yeah.
The reason that we know that pi is equal to 1, right, is because if you think about the information that's given, right, rats will eat 50% of any barley that's saved, right? Which means that if you were to store your $100, say that, or let's just use the barley example. Say that the pirates just saved the barley, right? They would have been able to consume 100 units of barley in period 1. But if they don't consume it in period 1, then they're only able to consume 50 units of barley in period 2 because of the fact that the rats ate 50%, right? And so now, basically what that's saying is you're able to afford 50% less, meaning that the inflation rate increased, right? Or that is equivalent to saying that inflation increased by 100%, and so now you're only able to afford half as much. Does that explanation make sense, or do you want me to go a little bit into it?
if you can go a little bit into it, because it's still kind of
Yeah, that's fine. So I'm trying to think. Let's use the concept of money for now, just because it's something that we're all maybe a little bit more comfortable with, right? So let's say that I have $100, right? And I'm buying gum, and the price of gum is $1, right? So in period 1, my $100 divided by the price of gum is $1 can get me 100 units of gum, right? However, in period 2, right, I have it that I still have $100 because $100 was saved, right? But I'm only able to afford 50 units of gum. And so what happens effectively is that the only way that this is possible is if the price of gum increased to $2, meaning that there was a 100% increase in the price of gum. Does that make sense?
Yeah.
Right. And so this is equivalent to saying that if I save my money, I lose 50%. But another way of thinking about that, which is what I've decided to do, is instead of saying that you lost 50% of your money, let's just say that the prices increased by 100%, because in terms of purchasing power, those two are equivalent to each other, right? But it's more useful to think about it in terms of inflation, because when you get to part C and they give you something about nominal interest, right? Now we have values for these two variables, right? Which is going to allow us to ultimately solve for 1 plus rho. Does that make sense?
Yeah.
And if more people are confused, I definitely recommend you guys speak up, because I think that this is probably one of the harder problems in all of the problem sets. It's something that I had trouble grasping when I first took the class, and it's only after like teaching this multiple times that I can like kind of fully grasp it. But you guys are going through this at like for the first time, so it's totally all right to be like confused about this stuff. It's tricky. Don't worry. I know it's tricky. But if there's no other questions about why the inflation rate is 100%, I'm going to move on with the question, if that's all right. So let's erase this. Okay. So we've already established that R is equal to 0.5 because, right, that's the effect of the garden, and inflation is equal to 1 because that's the effect of the rats, right? And so if I erase, let's just erase this, and I plug my values of R and pi in, I get 1.5 over 2. All right, this is equal to 3/4. And so I get that rho, or I get that 1 plus rho is equal to 0.75. Let's just say 0.75 for now. So now it becomes a lot easier of a question because of the fact that we know what this is. And so now if we go back to our budget constraint, C1 plus C2 over 1 plus rho is equal to M1 plus M2 over 1 plus rho, right? We can actually fill in values already, and we get that C1 plus C2 over 0.75 is equal to 100 plus 300 over 0.75, right? Because remember in part B, we said that they were stealing 300 bags in period 2, right? And so now we have a budget constraint that looks like this, where now we only need to fill in the values of C1 and C2, right? And like part A that we did, right? I have my MRS, which was equal to negative C2 over C1. We already established that there's diminishing marginal rate of substitution. And so now we're able to set this equal to negative 1 plus rho, right? The negatives are going to cancel out. And so we get that C2 is equal to 0.75 C1, right? And we know that this is 0.75 because we already established that 1 plus rho is 0.75, right? And so now we actually are able to plug this value into our budget constraint, right? And get that 0.75 C1, right? This is going to cancel. And so now I have 2 C1 is equal to 100 plus, so 300 divided by 3/4, 300 times 4 is equal to 400, right? So we get that 2 C1, and I'm running out of space here, but 2 C1 is equal to 500, which means that C1 is equal to 250, right? And then from here, we know that C1, or we know that C2 is equal to 3/4 of 750. So I'm just going to leave it as a fraction, but we're going to say that C2 is equal to 750 over 4. All right. And then that's the problem.
How do we get C2 again?
C2 we get because we know that C1 is equal to 250, right? And basically C2 is just 0.75 times 250, which is the equivalent of saying 250 times 3/4, which is 750 over 4. All right. So I think that, you know, I know that this solution was already posted onto Gaucho Space. I didn't get a chance to look at it, but if there's still questions about this, definitely refer to that. Or I guess you could refer back to the lecture that will eventually be posted. But yeah, so that's how you do this problem. I think that there's definitely some intricacies. I think that the idea of like the intertemporal budget constraint is definitely really kind of complicated. So I understand if it is tricky for you guys as well. So let's move on. I want to go on to problem set, or extra problem set 5. So if you guys want to open that up. Also, there's some messages in the chat that I didn't read. Okay, yeah, all right. So yeah, if you guys want to go on to extra problem set 5, we're gonna just kind of go through some of these questions. And I don't think we'll have the opportunity to answer all of these. Some of them have expected utility questions, which we're not going to have on the midterm, I believe. So there's no use in doing that yet. But let's see. Actually, a lot of it is risk. So we'll do like up until question 6 if we have the chance, because the rest is just expected utility. So this is extra problem set 5. And I say that, why don't we just start at problem number 1? And I'm going to let you guys, I want you guys to kind of work this out. And while you guys are doing that, I'll kind of set up the problem. And in about 4 to 5 minutes, we'll kind of reconvene. Or I guess when you guys give me some thumbs up in the chat, we'll reconvene. And we'll see what happens here. All right? So you guys go ahead and I'll do my thing. All right, if you guys are done with the problem, maybe give me a thumbs up in the chat. Or if you guys are still working on it, feel free to take your time. We'll probably talk about this in a minute or so. All right. So for those of you who are still working on it, you guys can either keep working on it, or I'm just going to go over what I've done on this for my work. And then maybe you guys can kind of just check back with what you've done and see whether it lines up. So the thing about this question is they don't ask us to do like multiple indifference curves and multiple budget constraints. So they're not asking for necessarily like to show you substitution or income effects. What they're really just asking is, how can you check the total effect, right? So I originally started off by just drawing my budget constraint. I think that it's always useful to just label stuff because when you label things and you get that something changes, like a exogenous change, right? You get to see which of your labels have that single input. And then from there, you know that if something changes with the input, something has to change with the output, right? So that's exactly what happens in this case, right? I have my original budget constraint drawn here. And then I'm given that this person is originally a borrower. And so I just drew like an arbitrary value for the endowment. So the endowment is M1, M2, right? And I made it so that he's originally consuming more in period 1 than he has for his endowment, meaning that he's borrowing money from the future in order to consume in the present, right? So he is originally consuming at this point right here. Then we're given that R increases, and we want this person to eventually turn into a lender, but also keep the same utility, right? And so that's like a little bit to unpack, but essentially we know that in order for that to occur, he needs to be to the left of his endowment, meaning that he needs to be consuming less in period 1 than he was given, right? What we also know is that it has to be on the same indifference curve as the optimal point, right, before anything happens. And so how we draw this change is, first, we recognize that when the nominal interest rate increases, right, we assume that everything else stays the same. So when 1 plus R, so when R increases, that means that the numerator, that means that the numerator of this fraction is going to increase, meaning that 1 plus rho also increases, right? And so when 1 plus rho increases, that means that the slope is going to pivot. So notice that we're pivoting around the endowment point. So essentially what's happening is that we're just going to rotate our graph so that it starts off like this and it rotates like this, right? And the reason that we know this occurs is because if you notice, our C1 axis intercepts, right? So our intercept on C1 contains 1 plus rho, and it has it in the denominator, meaning that this M2 term is now being divided by something greater than what it was. And so this is going to kind of move inwards. Likewise, this M1 term is now being multiplied by something that's greater, right? Which means it's going to increase. And so what we end up with is something that kind of rotates around the point of endowment. And that's something that I'm not sure if I mentioned, but whenever we're given an endowment and something changes, it's always going to be like a rotation through that endowment point. So like the buying and selling, I believe, is like a rotation. And so is this one right here. And so I've now drawn my new budget constraint. And I know that because this person is going to be optimizing, right? We just assume that they're a utility maximizer. We're going to say that this person is going to have their indifference curve be tangent to the budget constraint, which is exactly what's happening here, right? And so if you look at what's going on this diagram, this person goes from here to here, right? Meaning that they go from being a borrower to a lender. And this is a result of an increase in the interest rate, right? And they're keeping the same utility because they're on the same indifference curve, right? So all of these factors combined are what results in this diagram right here. So hopefully you guys didn't have too much trouble with that. So there's no income effect in this case, right? That's not necessarily true. I think that we would have to be given more information about that. But I don't think you can make that assumption right now. But I could be wrong. So let's just actually do that right now. Income effect, total effect. We know that the total effect for C1 is negative. The total effect for C2 is positive. The substitution effect, right? When interest rates go up, it now becomes more expensive to consume in the present, which means that consumption in period 1 goes down, consumption in period 2 goes up, right? But we don't know anything about the income effect, I don't believe, except that when interest rates go up, I guess it depends on whether you're initially a borrower or a lender. So if this person's initially borrowing, right, then an interest rate increase makes it more expensive to consume now. So I'd say that this probably goes down, and that this will probably, yeah, this one's a little bit confusing, and I don't know that off the top of my head. But to answer your question, right, there is going to be some sort of income effect in this question, right? You just kind of have to work that out. So I could go over how they're on the same utility. And that's simply because this point right here is on the same indifference curve as this point right here. And right, you know that because it's an indifference curve, any point right along that curve has the same utility, right? So that is how I would go about this question. I think that there's generally some ambiguity. So I know that you guys saw this during lecture, where there's some ambiguity when you do substitution and income effect with how people become like borrowers and lenders and all that. I don't know that off the top of my head, but I imagine that there is some ambiguity in terms of C2. Right, it could either be down or up. I don't think that there's a definitive answer, unless we were to kind of dive down with like, yeah, unless we were to kind of be given either numbers or be given more information. I don't think we know that right now. So if there's no other questions, I'm going to move on to problem 2. All right, I'll take it as no more questions. So let's move on to question 2. Same thing, I'll give you guys probably a little bit less time because I know that we only have 10 or so minutes left. So I'll give you guys maybe 2 to 3 minutes. It's okay if you guys don't finish yet. Yeah, I'm just gonna kind of go through this one a little bit quicker. All right. I think that this one is pretty straightforward, unless it's like a trick question that I'm also being tricked on. But I think that if the question is what I think it is, it should be pretty quick to get through the answer. And so I'm just going to go over this just real quick, and then we can maybe move on to question 3. So we're given that the person, so her optimal level of C1 is 30, and her optimal level of C2 is 130. So this is, right, given her utility function, right? This doesn't say anything about her like initial endowment. But the question asks whether this point is possible, even if she's a borrower. And so I think all you really need to show is that her M1 is less than her C1, meaning that she is consuming more in period 1 than she was given, right? Which would mean that she borrows against her future consumption in order to do so. So I think that's the correct answer.
So as long as C1 is greater than M1, then they can be a borrower?
Yeah.
Okay, thank you.
Yeah, I mean, that's kind of like the definition of a borrower. The opposite would be true for a lender, right? So I believe that's how you do this problem. Let me just check the answers actually, just to make sure that I'm doing it right. Yeah. I guess this is really just a quick question. So I think that the only issue that can maybe come up is you guys like think that there's something that they're hiding, and so that it's like you maybe overthink it. But as long as you don't overthink this problem, I think that it's pretty straightforward. You just have to kind of be familiar with what is a borrower and what is a lender. So let's move on to question 3. This one looks like it has numbers, so it might be a little bit more tricky. So who faces an interest rate of R equals 10%. And typically, if they don't give anything about inflation, you just assume inflation is 0. So let's kind of look at this question and see what's going on. And so R is given as 10%. And so we assume inflation is 0, which means that 1 plus rho is equal to 1 plus R, which is equal to 1.1, right? And we're saying that they're going to save $10 if their income stream is 100 and 100, but they'll also borrow 16 if their income stream is M1, M2 is equal to 200 and 200. So this is definitely something where we're going to have to draw out on a graph. And we're ultimately going to have to figure out like, optimal levels of consumption given this. We don't have to do like any MRS because they don't give us like a utility function. So let's just kind of look and see what exactly is going on here. So let's look at period 1, right? If they're saving $10, that means that M1 minus C1 is equal to 10, right? Which means that their value of M1 must be greater than their value of C1, right? And so let's just draw this initial budget constraint, right? Where this is M1 plus M2 over 1 plus rho, right? And this is M1 times 1 plus rho plus M2, right? This is equal to, let's see, 100 plus 100 divided by 1.1 is like 90-ish. I don't know. I think it's about 90.
Yeah, it's 90.9.
All right, cool. And this is 100 times 1.1 is 110. And so this is 210. All right. So we have these. I'm not sure if this will be like coming into effect, but I think it's just nice to be able to like label stuff. And we're given that their value, their initial endowment is 100 and 100, right? Meaning that they're going to be right here, right? And we're given that they're going to save $10, which means that their M1 has to be 10 units greater than C1. And if we already know that this is 100, we can just kind of move stuff around and get that C1 is equal to 90, right? So C1 star is going to be right around here, right? So this is like the optimal bundle choice, right? And so we get something that looks like this. We also know that if they're in indifference, or if they're budget constraint, it looks something like this. So C1 plus C2 over 1 plus rho is equal to M1 plus M2 over 1 plus rho. We already established that this is 190, right? And so we know that this is 90. So 90 right here. So that tells us that C2 over 1 plus rho is equal to 100. And so C2 is equal to like 110, right? And this is not like exact numbers because there is some approximations that we made. But this is like about 110, right? So this bundle right here is at 90, 110, right? And so there's our initial question that we solved, right? And so, yeah, we've already determined that C1 is 90 and C2 is 110. So we can actually kind of just erase this because we don't need to do anything more for this question. The second thing, right, is we were given a situation in which their endowment is 200, 200, meaning that it's going to be like higher on this graph. So we're given something like this, right, where this is equal to 200 plus 200 over 1.1. What is that? Nah, it's not really that important. I'm guessing it's like 180 or so. So let's just say about 380. And this is kind of the same thing. So 220 plus 200 is 420. So we have the axes right there. And we're given that their endowment is 200, 200, meaning that they're going to be like right over here, right? That's about 200, 200. And we're also given the fact that no, they're not going to be borrowing $16, which means that M1 minus C1 is equal to negative 16, which means that C1 is equal to M1 plus 16, which is equal to 216, right? So that means that they're going to be right over like around here, right? So you draw an indifference curve like that. And you also want to find out what this bundle is. So we do the same exact thing where we do C1 plus C2 over 1 plus rho. And I'm already just going to plug in the values of M1 and M2. Right? We already established that this whole right side is about 380. Right? And we know that C1 is 216. So that means that, and actually I'm going to push this right over here. So C2 over 1 plus rho is equal to 380 minus 216, which I believe is 164. Does that sound right? Yeah, 164. 160. Yeah, I'm just, okay, that sounds right. Which means that C2 is equal to 164 times 1.1, which I actually don't know off the top of my head. I believe it is like around 180, right? Which means that this bundle right here is going to be at 216, comma 180, right? And this is just like approximations. I think that if I had a calculator on hand, the numbers would be a lot more accurate, but that's kind of like the general gist of how you would do something like this. I don't even know if they want the actual bundles, but I gave it anyway. And are there any questions about this in particular? I think that this is generally like what they're looking for. And if you check the answers, which I'm actually going to do right now, I want to see whether my numbers were about correct. So yeah, this was like 182, and this was 111. So I was pretty close. But yeah. So I know that kind of like usual, I didn't get through all the questions that I wanted to, but I think that I'm happy with the amount of time we spent on each question, and hopefully you guys feel more comfortable about what we talked about. You guys are free to go. It is 1:51, so if you guys need to go, go ahead. I just want to remind you guys that I have drop-in at 2, and I have drop-in tomorrow at 1, and also that just remind you guys that next Wednesday, no CLAS is going to be doing anything. So yeah, I won't see you guys until Monday, and then Monday will be the last time that I see you guys before the midterm. So best of luck. If you guys want to stay behind and ask questions, you guys are more than welcome to. And if you guys want to go to my drop-in, you guys are also more than welcome to. I get pretty bored during those, so yeah. But yeah, good luck, guys, and thanks for coming to my drop-in or to my lecture.